a new open source dataset for pre-training large language models. You can use this today, and the dataset here is so high quality that maybe it's at level at OpenAI or these research labs that are building their own private closed datasets for pre-training their own LLMs. You can find it on HuggingFace by searching its name, EssentialWeb V1.0. We present EssentialWeb V1.0, a 24 trillion token dataset in which every document is annotated with a 12 category taxonomy covering topic, format, content complexity, and quality. And then they used SQL-style filters to obtain competitive, well-curated datasets in math, web code, STEM, and medical. It's available on HuggingFace. You see here that training data, pre-training data is growing for all of these models. So this is trillions of tokens. This is a year. And we see for Llama, it goes from maybe 2 trillion tokens all the way to 30 trillion tokens, which is crazy. DeepSeek also like 3 maybe trillion to 15. And Qwen from 6 trillion all the way to 36 trillion tokens, which just shows that we need a lot of pre-training data. So instead of you manually needing to, for example, classify all of the data into mathematics, or you want to extract just medical data, this is the traditional way. It takes weeks to months to do that for every lab. They already have done all of that. They labeled the data. So now you just need hours to days to accumulate all of the data that you need to just select the data that you need, because they've done everything for you already. They classified it. So besides being able to train your LLM on this entire dataset, you also can pick highly specified, highly specialized, just mathematics or physics, or I don't know if it's physics, but medicine and stuff. We'll see later what they have. So each document is tagged with subject, complexity, format, and quality. So now you can just query for all documents about medicine that are academic papers or textbooks and that are technically correct, for example. So it turns a month-long task of creating a high-quality training dataset into a simple, minutes-long database query. So the previous datasets like Common Crawl, it's massive, but it's too noisy, it's unorderly, and if you want to select just mathematics, it would be very difficult as well. You need to do it manually. And it's not nearly as processed as this new dataset that they are releasing. This dataset is filtered and deduplicated a version of Common Crawl, so they just did all of the processing for Common Crawl that big companies do. To label these documents, which are web pages or books, for example, they used Qwen 2.532b instruct, but this was still too slow for this huge 23 billion documents. So they distilled that into a 0.5 billion parameter model. So that's 64 times smaller. And they call it EAI distilled 0.5b. So now they use this model, the small model, to annotate, to label the documents. But it still required 90,000 GPU hours to process all of these documents. This is a huge one-time cost they paid, so the community doesn't have to. So they found that now you, with just some query, you can create better datasets than professional companies are doing by processing the entire Common Crawl. And they tried training a model with their data or continued pre-training, and they find that on math, web coding, medical, STEM, they all perform pretty well. Let's take a step back. So while they were developing the taxonomy, while they were labeling data, they followed these five steps. Taxonomy development, so they chose the metrics, then choosing the teacher model. They tried DeepSeek v3, this Qwen 2.572b, and it looks like they chose 32b, and then they distilled that into the student model, and then they processed all of the documents, and then they measured and they curated datasets for the math, web code, And then in the end, I think it's not shown here in this graph, but they pre-trained the model and made sure that these datasets are good. So to test their datasets, they first pre-trained two base models. One is general base, 100% web data, and code base, 50% web data and 50% code data for 320 billion tokens. You see here they have this learning rate warming up here and then decaying gradually. It means that gradually, so in the beginning when learning rate is highest, then model weights are being updated most, so it's learning most in the beginning, and then later they have this decay, so later data will influence the training less and less, which is good for stable training. Maybe it already learned all of it, a lot of stuff here, so you don't want to let this new stuff change the model too much. And those would be the two models. This blue would be the general base and the code base, two separate bases. And then after that, they continued pre-training with domain-specific knowledge, domain-specific data like math, STEM, etc., to test these datasets and to benchmark them later. So, for example, for math, they used general base for the annealing experiment. So they train math, find this dataset on top of general pre-trained model and not the coding base. So they then measure their dataset versus these other datasets, and it looks like their dataset is better than all of the other open source datasets instead of this one. Find Math 3+. But they stress that all of these datasets spent a lot of time, maybe weeks or even months to build them, while their dataset can be built in like hours or maybe days at maximum. One thing that's a bit annoying, or I don't understand, they choose 8-shot, 4-shot for this dataset, 5-shot for this. So I don't know if they handpicked the best results. Maybe they try like 4-shot, 2-shot, 1-shot, 0-shot, and they have best performance at 8-shot compared to other datasets, so they pick one. Or why did they choose this? Why did they choose these seemingly random, like 8-shot, 4-shot for this one, 5-shot for this one? Maybe they have explanation somewhere, but I don't see it here, so I think they should write explanation like right here, so I can see exactly why they chose these specific amount of examples for every benchmark. However, I still believe the dataset is really good, and the fact that it can be curated very quickly by the users, we just need to do some query, and I think at worst it's as good as these others, if not better. So I think it's very good. So they generally score high benchmarks, good benchmark score on medical tasks, on other domains like code, STEM. Here you see you have MMLU STEM, and they have this highest scores. Here we can see how much information is shared between different taxonomy classes, and you want as little as possible, so each class is giving unique valuable information, and you don't want redundancy. So knowledge domain and the knowledge domain will obviously have 100% same information, same types of data and taxonomy, while other classes are gonna have very little overlap, which is good. It means that these classes are well classifying and well distinguishing between different types of documents, and they possess unique data not shared with other classes mostly. Next steps, they see this taxonomy and classifying data as a way to structure data, and this could be the future of structuring data and preparing it for large neural network training. I recommend you read the ablations of this paper as well if you want to use this dataset. They show examples of some algorithms on how to filter data. Thank you for watching. You can check other videos on my channel, and see you next time.